Hi, my name is Sam. Today we are going to be answering some questions about alleles and allele frequency, and we're going to be using some Punnett squares. Let's start with cross A. The mother is chocolate and the father is cream. Now, as we can see, everything else is dominant to cream. So for the father to be cream, both of his alleles must be F4. So in my little Punnett square where I'm going to begin, I'm first going to label this side father, and then I'm going to write F4 on both sides, both on the top and the bottom. All right. Now we have to look at the mother. Now, in order for the mother to be chocolate, she has to have at least one allele, that is an F3. And in order for her to be chocolate, she can't have anything higher than that. So no F1s and no F2s. In order for some of her offspring, however, to be cream, they must have inherited one cream allele from her and one cream allele from the father, meaning the mother must be F3, F4. So we'll write those on top. F3, F4. And these are the mother. Now we can write in the full possible allele combinations for the offspring. So they'll either be, we have F3, F4, F3, F4, 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 and F4, F4. So we can see that 50% of these offspring are F4, F4, meaning that they will be cream. The other 50% of the offspring are F3, F4, meaning that they will be chocolate, like the mother. And that has A. We have answered the proportion of each progeny type and the possible genotypes for both parents. Now, both parents can only have those genotypes in order to produce these phenotypes in their offspring. Great. Let's move on to cross B. Now, all the progeny is black, so we're not going to create a Punnett square since we don't need to determine anything about the progeny. The mother is black and the father is chocolate. So all we need to do is list the possible phenotypes of the parents. Now, for the mother, because she's black, she needs to have at least an F1, at least one F1. Then, after that, she could have two F1s. So she could be F1, F1. She could be F1, F2, F1, F3, or F1, F4. For the father is chocolate, so he can't have an F1 at all or an F2 at all, or else he would be sable or black. So he must be an F3, and after that, of course, he can only have either an F3 or an F4. Those are the only possible phenotypes for the father. Great, that's B. Let's move on to C. Mother is black and father is sable. Progeny types include black, sable, and cream. Ha! In order to get any cream offspring, each parent must have one cream allele. So they each have to have at least one F4. So I'm going to write those down. F4. One on the top and one on the bottom. Okay? Now, the mother, as they told us, is black. So she gets an F1. All right. Now the father is sable. In order for the father to be sable, he must have an F2. He must. From here, we can fill in our Punnett square. We have F1, F2, F2, F4, F1, F4, and F4, F4. What this means is that 50% of the children, of the offspring, will be black, 25% of the offspring will be, our F2s will be sable, and 25% of the offspring will be cream. That is C. Now for D. D, we have a black hamster of an unknown phenotype, and we need to figure out the best cross we could set up to determine the genotype of this animal. Now, she's black, which means that the mother, I'm going to call her a she and decide that she's the mother. I'm going to decide that she must have an F1. We don't know what her other allele would be. The father, or the other creature, can have any alleles. But I'm going to contend that the best alleles to choose will be F4, F4, or F3, F4. Either way, we will be able to see in these other two creatures that half of the offspring between this mother and this father will always be black because the mother has the F1 gene. But if the other two alleles that the father has are F4, both of them, or F3 and F4, we will be able to see the other phenotypes expressed in half or 25% of the rest of the population of those children.